Hi, and welcome back. In this lecture, I'll talk about GPS, and in particular, how to connect a GPS serial breakout to your Arduino. I'll spend most of the time talking about this breakout, the Adafruit Ultimate GPS Breakout version 3, which is probably the easiest way to get started with GPS and your Arduino. There are alternatives, of course, and one that stands out is this module here, PCI 5S500 module. It's a little device that I'm experimenting with at the moment, and that's why you can see these wires sticking out. So something like this, also a serial GPS device, costs only about $8.59 on eBay, as opposed to the Adafruit version. It's about $40. But the nice thing about Adafruit is that it's got a few user-friendly features. For example, it's got an integrated antenna, although you can connect an external antenna via this connector here, and a couple of other features that I'll talk about very, very soon. On the other hand, bare bones GPS breakout like this one is something that you buy in order typically to install inside a laptop computer or an embedded device. And in order to use it with your Arduino, you'll have to stick wires to these pads over here that give you a serial transmit and receive data plus power. So I'll be coming back doing another lecture using this breakout. So back to Adafruit. So this is the Adafruit breakout, and a few nice things that come standard with it are things such as an LED right here that shows you when the device is looking for a satellite and when it finally gets a fix. It also gives you access. Let's have a look at the information here. It also gives you access to external antenna via this UFL connector. So to this connector, you can plug in an external antenna like this, which is what I'm going to be doing soon, or one with a much longer lead, which is good if you want to put it in something like, say, the boot of a car. If you want to create a car movement tracker, you're going to have to connect an external antenna. So that's a nice feature. Other things that are worth talking about is that you can connect 5 volts directly through the VIN pin. It's got its own voltage regulator. It's got full serial communications with your Raspberry Pi or with your computer, which is going to be the first of the experience we'll do. So receive and transmit pins over here. There's a fix pin, which basically notifies perhaps a peripheral of the fact that the GPS module has had a fix. It's got a fix with satellites, so you can use it to light up an external LED, for example, if you don't want to have the internal LED consuming power. On the other side, there's a connector for batteries. So the module comes with its own real-time clock, and you can have a battery connected to it in order to maintain time. If you do plug a battery to it as well, another benefit is that the module will keep information about satellites, so that the next time that you power it on, it will get a much faster satellite fix. So without the battery, even externally in my experiments, it takes maybe about a minute, maybe 2 minutes sometimes to get a fix, depending on the conditions and whether you've got trees around and buildings and so on. So the battery is a nice addition. The chip that implements the GPS functionality also has a little bit of EEPROM memory available that you can use to do data logging. So the Adafruit library comes with data logging examples. So the nice thing about this embedded EEPROM is you can record up to 16 hours of location information on it. Also, there is an enable pin right here. This enable pin allows you to turn off the device from your microcontroller if not in use. That way you can conserve power if the GPS is not really required. So all in all, a really nice device here, a very good way to get started with GPS and your Arduino. A couple of other things that I want to show you before we move on with the first demo is that GPS devices, whether they are the Adafruit module or the Toshiba module, send out data in serial, and the data are standardized to speak a particular dialect or sentence that's called NMEA. So as I'll show you later, this device the Adafruit device also uses one of these standard dialects. I believe it is, let's see, I'll have to come back to this later. But this website here gives you GPS information about all of those types of standard sentences. So they explain, they give examples and they explain what each of the components of output is. So for example, you can see here, GPGA spits out all of these bits of data. And this is where you can come and find out what each one of these fields of data really mean. So for example, you can see that this part of the output is the latitude. And this part of the output gives us the longitude. Now, once you have data exported via serial from your GPS, you could use a bit of text parsing to extract the individual components, as I'll show you in a minute. You can also use a little handy utility like this, free and online GPS visualizer. You can upload a data capture text file from your GPS module, and then you can put it on a map. You can choose one of your formats, or what kind of map it's going to be, or what kind of file you'd like the parsed output to go into. I'll give you a demo of this as well. So in this lecture, the first thing we'll do is to connect the Adafruit GPS module to my computer directly. We'll be bypassing the Arduino, and we'll extract some serial raw data out of it, and then use the GPS visualizer to put the data on a map. After that, I'll use the Adafruit library to show you a few nice things, including the way by which the library can help you to parse the GPS module output, so you can use parsed output in your sketches. Then I'll show you also an alternative library called TinyGPS, also very popular, which has some very nice features worth talking about. Okay, so let's get started with the first demo.